Man, what shoot?
Man, this button right here, the X button is for passing. You need to use that button.
Just shut up, man.
Yeah, what do you expect from an American, man? You guys don't even know how to play soccer. You call it soccer.
Whatever. I've been thinking lately, and what do you think about life in the universe?
Like aliens?
No, not like aliens. Well, maybe like like another Earth out in the galaxy, like another species out in our universe.
You know what, man? Actually, I hadn't been thinking about this, right? I was thinking about theory of evolution and the necessities for life, and is there life on other planets in our solar system, or like maybe in other galaxies, and like are there any other type of civilizations out there, and what kind of civilization are they? Are they monkeys, or are they a lot more advanced than us, and they might have visited Earth before and we don't even know if they did?
Yeah, exactly. That's exactly what I was talking about. With comparing Earth to other planets, Earth has fossils that date back 3.5 million years ago. They have carbon isotopes that date back 3.85 million years ago. Life, therefore, is a few 100 million years old.
Yeah, so you can see that everything took a lot of time to happen, right? Because I was reading Charles Darwin's theory of evolution, and it said that at first, the first type of life was only small organisms, alright? And there was another overproduction of life that leads to competition for survival. And between two individuals, one of them is stronger, like they're not alike, they're different.
Yeah, like natural selection. Out of those two individuals, what characteristic of them is stronger and which one is going to go into the next generation and evolve?
Right, but you know, for all this to happen, there's some necessities for
Dude,
life.
just hold on.
Man, what?
Dude, look at this.
What is this, man?
Dude, I'll tell you what this is.
Right.
In here, there's info.
Why don't you let me see this?
No, I'll tell you. There's data that I've been collecting because I've been thinking about this, and I just put it all together in here.
Alright.
And you said necessities of life, and it just, in here I have, like, Earth has to have certain needs to live, just like another planet would.
Right.
And for Earth to live, the first necessity is it needs nutrients for living cells.
Okay.
The second one is you need a source of energy to fuel the activities of life. Okay. That source could be sunlight, chemical reactions, food, or just the heat from the Earth itself. And the third rule is you need liquid water.
You know, for all this to happen though, the planet needs to be in the habitable zone from its sun.
Yeah, right? Dude. With habitable zones, they can't be too hot or too cold. It can't be too dry, and the atmosphere has to be right.
No, man. You hold on, right? You show me your research. Let me show you something. Just come with me.
Go where?
Just put your shoes on and come with me. Here, man. Come over here. Okay.
Why do you have me all the way over here now, man?
Take a seat.
All right.
You showed me your research about the necessities of life. I'll show you my research about the habitable zones in our solar system and in our galaxy. Okay. This right here is our solar system. This is the Sun. This is Mercury and its orbit. Venus, Earth, and Mars. The green zone is the habitable zone of our solar system. Okay. If life can be created in our solar system, it would be between this zone. This is because the surface temperature of the planets orbiting between this zone, it's at which liquid water can exist. Although there's some requirements for the star so that life can be created. For example, the star, our sun, needs to be old enough so that life could be arising. And it also needs to allow the planets to have stable orbits, like Earth and Mars do. So we will look for life in our solar system after Earth, the best candidate would be Mars. This is because we believe that Mars once had conditions that were conducted for life to be created. Because when we look at its surface, we can see craters and tunnels that show us that liquid water can exist. If that happened, liquid water on Mars can still exist in liquid pockets underground, possibly near to volcanic heat. Although Mars is not the only place we will look at in our solar system for life. Jovian moons, Europa, Ganymede and Callisto, they have futures where they could probably have oceans. Now, if we will look for life outside our solar system, for example our galaxy, we will look between this green zone in our galaxy. This is the habitable zone of our galaxy. You can see that it's a small region. It's only 10% of the galactic disk. But if we want to find Earth-like planets, it would be in between this zone. But you know, this then makes me wonder, like, are there any civilizations in this zone?
Well, dude. Well, do you know, I've also have been doing some research here, and voila, as you can see.
What is this?
This is the Drake equation. In this equation, you have this variable, which stands for the number of habitable planets in our galaxy. This variable is the number of planets which have life in our galaxy, and this variable is the variable that has, it's the number of civilizations that once occurred in our galaxy, and this variable is how many civilizations there is now in our galaxy. And when you take these two variables in time, times them together, you get life-bearing planets. When you take these three and multiply them together, you get the number of planets which has evolved or developed in history. And then when you times them all together, you get the total number of civilizations in our galaxy, as you can see here.
Right. Okay, this is pretty good research, man.
It is nice research, dude. Makes you wonder if there's really aliens out there.
I think there must be some aliens out there.
You have to get something out of this equation.
I mean, that's something, right?
Yeah.
There's something here.
Alright.